All right, mathletes, here we go. It's linear inequalities. So, linear inequalities can look something like this. 5x minus 2 is greater than 7. That's an example of a linear inequality. Okay. Another way of thinking of this is the expression 5x minus 2 is greater than 7. Okay. So typically in elementary type schools, we teach it as that if we think of this as the mouth of a fish, okay, the fish is always eating the larger of the sides. So 5x minus 2 is greater than 7. Okay, an algebraic inequality is a mathematical sentence. Okay, it compares two expressions. So instead of saying something is equal to something, we're saying it's greater than. Okay, using the symbol like this. Okay, it's less than, the symbol like this. Okay, is greater than or equal to. So if the line underneath, we think of that as equal to, and usually it's not necessarily out like that, but more just kind of horizontal there. Okay, and less than or equal to, or like that. Okay, so we can say things like 5 is greater than 4 here, or 4 is less than or equal to 5, but we could also say 4 is less than or equal to 4, and that's also true. It's equal to, or it can be less than. Okay, so here we want to rewrite the following inequality with the variable on the left hand side. So when you switch things around, you also have to switch around your inequality. So if I want to put x over on this side, remember, this is opening up towards x. It still has to open up to x. So x is greater than 8. It is the same thing as saying that 8 is less than x. So recognizing that symmetry there is important. Okay, same thing here. I can say that y. So here, this expression I'd read as 1.5 is greater than or equal to y. Is the same thing as saying as y is less than or equal to 1.5. I always double check. Where is it pointing to? Here. Y, it's pointing to y, so it's got to point to y there. Okay. So next slide here. Solutions to linear inequalities. Okay. The biggest idea we want to understand with linear inequalities is that there is infinitely many solutions here. Okay, unlike when we're solving equations and we say that x is equal to 2, typically we have one solution. Okay, although there's multiple ways we could write 2. We could write 2 as 2 over 1 or 6 over 3. It has one solution. But when we say x is greater than 2, there's an infinite amount of solution. Think of all the numbers that are greater than 2. It goes on forever. So we have to somehow talk about how we can show and display solutions of an inequality. Okay, so using a number line is a good way of showing our solutions, because we can show solutions as they go on, infinitely small or infinitely large. Okay, so we're always going to use arrows to show our solutions in which directions they are going. Okay, if the sign is strictly greater than or strictly less than, okay, we use open circles. So notice these are open circles, not filled in. Okay, if we're talking about greater than or equal to or less than or equal to, we have closed in circles. Okay, so I think of it as the bottom of the little equality line there goes in. So that was from this piece. Okay, and this piece requires it to be colored in. Okay, so it's a closed in circle when you have an equal to sign. Okay, so if I wanted to express x is greater than 2, I put a circle at 2, and it's an open circle because it can't be equal to, and all the values that are greater than 2 need to go off in the right direction. Sometimes it's just nice to find a solution and then draw your line to that. So if I think of a number greater than 2, I know that 4 is greater than 2. I could make a little mark, and then I know I have to draw it out in that direction. Okay, so let's look at a couple examples here. So a is greater than 1. So I'm going to go over to 1. Okay, and I'm going to notice that 1, a is strictly greater than 1, so it's going to be an open circle. Solutions to this problem, I could say that 2 is greater than 1. So 2 is off in this direction, so that means that's the direction of my arrows. So all those solutions off to the right of 1 satisfy that inequality. Okay, so next one, a is strictly less than -1. So I go over to -1 and I think strictly less than. So that's an open circle. What kind of solutions are less than -1? Well, I could say -3 is less than -1. So -3 is in this direction, less than, I'm off in that direction. Okay, and the next one, D. I go again to -1. Okay, and then I think it's less than or equal to, so less than and equal to, so I'm going to have a solid filled in circle, values that are less than -1, so things like -3. So that means I have to shade my line off in that direction. Okay, final one here we're looking at, a is greater than or equal to 1, so I can go to 1. That's going to be a filled in circle because it could be equal to. Values that are greater than a, things like 2. So I put a dot at 2. I know I need to draw my line off in that direction. And I have my illustrated inequality. That concludes our notes for tonight. Make sure you bring any questions to class tomorrow.